Okay, so last section we're going to look at in chapter 1 is 1.6, and it's on different operations we can do with functions, including a special one called composition. So what we're basically going to look at is, I'm going to give you two different functions, and we're going to combine them together to make a new function. And four basic ways you can combine existing functions is just to use addition, subtraction, multiplication, and division. Now, what this is going to tie in a lot with is domain and range. Because anytime you create something new for a function, you have to be careful that you don't do two things. First thing, you don't ever want to take the square root of a negative. Second thing, you don't ever want to divide by 0. So if you somehow introduce that situation, when you talk about the domain, we got to be careful. Okay. So here's an example of two functions. Function f is x squared, and function g is the square root of x plus 1. Now, sometimes when you combine the functions, there isn't really a lot of simplifying you can do. So I'm going to combine these two functions by adding them. And when I do that, there's not really anything I can do. So if I take f of x and g of x and add them together to create a new function, I get x squared plus the square root of x plus 1. And that's it. So now this is a brand new function, which if you drew that, would look different than either of the original. But it's a combination of the two of them, just added together. Now, if f of x was x squared and g of x was 2x squared, then when you added them together, you could combine like terms. X squared plus 2x squared is 3x squared. Okay? In this case, there are no like terms to combine there. So any questions on how I created the new function f of x plus g of x? And sometimes we'll name that. Maybe we could call this new function h of x. So h of x is f of x and g of x added together. I didn't name it here, but you could. Okay, the next one I also haven't given a name to either. I've just said, well, it's f of x divided by g of x. And that's literally what I'm going to do. F of x divided by g of x. So I've created another new function by combining two other ones using the operation of division. Now, the only thing you might see in a problem like this, if that was a final answer, we generally don't like to leave a final answer like that. How come? What's wrong with this? The one above it's okay, but the one below it, not so much. Emma?
Because there's a square root on the bottom?
Yeah, there's a square root on the bottom. So generally when you want to have a final answer, we get the square root out of the bottom by multiplying top and bottom by the square root. All right. So now in the top, you have x squared, square root of x plus 1. Can't really do anything with that. But in the bottom, you've got the square root of x plus 1 times the square root of x plus 1, which is how much? Yeah?
X plus 1.
X plus 1. Square roots cancel. So that's a little bit nicer of an answer. Okay, on a test, it would be good if you do that. Okay, don't leave square roots in the bottom. And that's the function f of x divided by g of x. Okay, any questions on that? And there's more examples on page 58. I'm just showing you a couple quick ones. Now, the domain. So, if you know the domain of f of x, and you know the domain of g of x, that's a good start. But when you take these two and combine them together to create a new function, the domain might change a little bit, okay, depending on how you combine them. So that's what I'm going to explain right now. So the first thing you have to figure out is, what is the domain of each original function? So you do that, and then the domain of the new function is all x values, such that those x values belong to the domain of both original functions. Okay, we have to pick values that work in both. So in other words, you have to use the more restrictive domain. So if one function said you could use all real numbers, and the other function said, well, you can only pick numbers greater than 2, then you're limited to numbers greater than 2. Even though one of them said you could use anything, the other one didn't. So you got to use the more restrictive domain. Let's go up and look at, actually we'll do some examples. We don't have to look at that one. Now, there's one catch with that, and that comes in with what we did right here. We created f of x divided by g of x. By creating a new function that has division, what problem could we have just created that wasn't there originally? Oh, Justin?
What's the question?
What problem could we have just created right here that wasn't in the original problems? It's an issue we have to deal with now.
I'm not sure.
You want to help him out? Yeah?
Can't divide by 0 or can't have like a 0 in the square root.
Yeah, we can't divide by 0. Okay? F of x was not a fraction, neither was g of x. But when you combine them using division, you just made a fraction. So now you've created a problem in the bottom, right there. So when we talk about the domain, we have to be careful that we never divide by 0. Okay, so not only does the domain have to be part of both original functions, it also has to be a number that would never cause the bottom to be 0. Okay, so we'll practice with some functions now, kind of identifying domain. And then eventually, we're going to do range too. Domain you should be able to do without a calculator. Range can be a little tricky until you kind of get used to what graphs look like. So we'll use a calculator, which I didn't unlock. But as I go through it, if I think you need one, I'll definitely unlock them so you can use them. Or if anybody wants one, just let me know. But I don't think we're learning anything new on the calculator today. I don't think. All right. So here's our two original functions. And in a minute, I'm going to combine them together in some way. But to do that, or to combine them and then figure out the domain, I have to know what I'm starting with. So Blake, looking at f of x, what's the domain of f of x?
X can equal anything other than -3.
Can you say it again?
X can equal anything other than -3. Or -3 or higher.
-3 or higher. Can it equal -3?
Oh, no. Because you can't have a 0 in the square root.
No, you can.
Okay.
You can have a 0 in the square root. So it's any number greater than or equal to -3. So we're going to write from -3 bracket, including it, up to infinity. Okay, how about Joe, what's the domain for g of x?
Anything greater than 2?
Not equal to 2?
Equal to 2.
Greater than or equal to 2. If you go lower than 2, you're going to have a problem. You're going to take the square root of a negative. So, just looking at those two domains, I know they're both infinite, right? Because they both go to infinity. But which one is more restrictive? The domain for f of x or the domain for g of x? Yeah, Chris?
G.
G, I agree. F says you can pick any number -3 or higher. G says 2 or higher. So this entire domain is included in that one. Okay, so g of x is smaller. I know it goes to infinity, but if you think about it that way, it kind of helps. Okay, so g of x is more restrictive. Now, we're going to combine these together by adding. And there's not really much you can do. You're just literally going to write what you see. So it's f of x plus g of x. Now, the domain for this new function is all x values that would work in both of the original. So Kaylee, can you tell me what the domain would be for example A?
Would it be the domain of g of x?
Yep, the domain of g of x. You can pick any number from 2 to infinity. And you're saying, well, wait a minute, you could plug in like 0 into the first one. 0 plus 3, square root of 3, no problem. Yeah, but you can't plug 0 into the second part. 0 minus 2 is negative 2. So it's got to be numbers that work in both. Questions on that? All right, let's try a division one. So f of x divided by g of x. So I'm going to start out with the square root of x plus 3 divided by square root of x minus 2. Now I'm not as worried about cleaning up the square root in the bottom because, well, I guess writing the actual answer is part of the problem. The domain is part of the answer, and then what I put in the boxes. So we can clean it up if we want by multiplying top and bottom by the square root of x minus 2. And now what you get in the bottom is just x minus 2. But in the top, you can combine those. Okay? They're both square roots. So if I had like the square root of 3 times the square root of 2, that's the square root of 6. You can do that with multiplication. So if I wanted, I could put these all together. The only disadvantage to doing that is once you combine them, it makes it very hard to figure out what the domain was originally. So I think what I'm going to do is leave them separate. Okay, that's probably easier so you can see what's happening. If you combine them, you'd have something like x squared minus 2x plus 3x minus 6. But it's easier to leave it like that. Okay, so we already know the original domains. We did those. So at a minimum, we have to at least pick numbers that are in the most restrictive domain, from 2 to infinity. Is this domain going to be the same as the last one, or different? What do you think? Yep, now?
It's going to be different because you can't divide by 0.
Okay, so what would the domain be this time?
It would be 3 infinity.
What about 2.5?
Yeah.
You could use 2.5.
So it would be anything above 2, not including 2.
Yes, anything above 2, greater than 2. So the domain here, 2 to infinity. Very similar to the last domain, but you can't use 2 this time because you divide by 0. Okay, any questions on that one? All right, so let's try this one. So graph and find the domain and range of this. All right, so we'll use the calculator to graph it. So f of x is the absolute value of x, and g of x is x. Let's write that out first. So this is going to be the absolute value of x divided by x. What do you get? Let's pick a value for x. If x was 2, and you fill it into the formula I just wrote, what would the answer be? Yeah, like 1. What if x was 5? Well, Gabe? Just plug 5 into that.
That would be 1.
1. What about if x was 13.4? Yeah. 1. We're getting 1 a lot. What if x was negative 5? What would the answer be there? It would be negative 1. If it was negative x was negative 8, it would be negative 1. So that should give you a hint about the range. The range is pretty small. There's only 2 numbers in it, 1 and negative 1. So let's graph that and see what it looks like. You can plug in any number you want for x, except what number are you not allowed to use? 0. Can't use 0. So we've got absolute value of x divided by x. Let's just do zoom 6. And there's your graph. Notice if you're less than 0, the answer is always negative 1. If you're more than 0, it's always positive 1. That's what I was trying to show you with examples. So, domain, all reals except 0. Or, again, I'll show you one more time, but you kind of got to get used to learning the interval notation on your own. You can pick any number from negative infinity up to, not including 0, or you can go from 0 to infinity. So there's your domain. And the range, normally you can't list every single number in the domain or range, because if they go to infinity, it's kind of hard to list every number to infinity. But this one only has 2 numbers in the range, so you can actually list every single number in the range. 1 and negative 1. Range 1 and negative 1. It's not everything between 1 and negative 1. It's just 1 and negative 1. That's it. And there's your graph. Okay, questions on that? You didn't get that graph? And did you type in exactly that? Absolute value of x divided by x? Oh, you got it?
Yeah.
Okay. All right. So another way we can combine functions, besides adding, subtracting, multiplying, or dividing them, is composition. So composition, basically the simplest way to explain it, is when you plug one function into another function. An entire function gets plugged into another function. Okay, I'm going to do some examples with numbers later on. It's less important that you know how to evaluate with numbers. It's more important that you can do this with variables, like here. So, to do composition, you need two functions. So I've got g of x and f of x. And this is the notation that I'm going to use. Okay? This is g, and when you see a parenthesis, you pronounce it of. So g of f of x. All right, so off to the side, let's say I said to do g of 4. What does that mean to do? If I asked you to find g of 4. Evangel? Yeah, you take what's right here and you fill it in for the variable. Okay, if I asked you to do g of 6, you would take 6 and plug it in for the variable. If I'm asking you to do g of f of x, take what's right there and fill it in for the variable. Okay, oops, I don't know why I erased that. So g of f of x is the square root of, and now fill in what they're telling you for the variable. It's not a 4 or a 5. It's an f of x. And now we know what f of x is, so we can actually write it. It's the square root of x squared plus 3. And what we just did there is we just composed two functions. That's how you do it. Any questions on that? We're going to do quite a few more. Now, if we do it the other way, instead of g of f, f of g, do you think they're going to be the same, or do you think they're going to be different? Any guess? Yeah, Emily? Yeah, they're going to be different. If they do come out the same, that means something. We're not worried about what that means right now. But in general, they're going to come out different. So let's look up at this. This is saying take that and plug it into function f. So I'm going to look at function f. Okay. I'm going to take this and plug it in. So take whatever they give you and fill it in for the variable in f. So we're going to get that part. That's just function f. And now plug in g of x. Square root of x. Any questions on what I did there? So plugged in g of x for the variable. Now, what happens there? The square root of x squared. Yeah?
It just becomes x.
Just becomes x. Now, you think, oh, nice and simple, right? Well, you got to be very careful when you write the domain, because by squaring and square rooting, you cancel out a square root. Square roots are something we need to be careful with. We're not allowed to take square roots of negative numbers. So you just wiped out something that was very important. It's okay to do that, but you have to remember that you did that when you go back and find the domain. And we'll talk about how to find the domain right now. Another way you might see this worded, I'm just trying to show you this because sometimes the directions in the book are confusing. So this says, find the composition of f by g. You might see this notation. I think that's confusing because if you see it in that order, like I like to just write it in the order that it's supposed to be. So that's why I always use this notation. And then you know f is the inside and g is the outside. But when you write it this way, composition of something by something, it's like the two letters get switched. So you're never going to see me write it as composition of f by g. Okay. I'm always going to use this notation, or you could see this notation too. That's like a g, a small circle, and an f. These mean the same thing. I'm okay with the g, the small circle, and the f because at least it's in the order, the way we're used to writing it, versus the way it's written up above. Okay, so to find the domain, you shouldn't need a graphic calculator. There's two things you have to do. The first step is look at the inside function. And I ask myself, looking at the inside function, are there any values that I need to eliminate? Okay, so what I mean by inside function, I mean this one. In this case, g of x is the inside. In this case, f of x is the inside. So just look at the inside function, which they're always going to give you in the original problem, and ask yourself, are there any values that I'm not allowed to use in that function? So you start with that. The second part is now look at the final answer. Okay, when you compose functions, you may create square roots where they didn't exist before. You may create fractions where they didn't exist before. So you've got to look at the composed function and see, okay, based on what I did, Is there anything else I need to exclude now looking at the final answer? And the domain is all numbers that satisfy both of those. They have to work in the inside function, and they have to work in the final answer. That's the key. The inside function and the final composed answer. Okay, so we'll practice composing some more functions. And now we're going to find the domain. Okay, so here's your two functions. F of x is x plus 1. G of x is the square root of x. And let's... does anyone feel like they need to do a numerical, or want to try a numerical one? Just to see what it's like just plugging in a number? That's easier than doing what I did on the last page. Anyone want to see one with a number? How about Gabe? Could you just explain to me how you would do that? I'm sorry, Gabe. Yeah. All right, so we need to, let's take a look at it then. Can anyone tell me how you would do it? Because I might ask you about that on the test. Yeah?
You set it up so that it would be the square root of 9 plus 1.
Yep, so you're going to, for now, you're just going to leave the f. You're going to plug 9 into function g. You start on the inside, you work your way out. So plug 9 into function g. So if I plug 9 into function g, I get f of the square root of 9, which is really f of what? 3. Now I have another calculation to do. What's f of 3? So look at function f. F is x plus 1. You fill in the 3, and you get 4. Okay, so that's just a basic example. Doing composition numerically, not really something we care a lot about in pre-cal, but we're more interested in domain and range stuff. Any question on how to do it? Okay. So let's start by finding f of g of x. Doesn't look like they asked for the domain yet. I think that's going to be an example for find the domain. Okay, so let's just practice 2 more compositions, and then we'll do domain. Okay, so let's start with f of g of x. Can anyone tell me how you don't have to give me like the final answer, just tell me how I would start to set that up. Well, Ryan?
Plug the x into the x one, plug one into the other.
Okay.
I don't know which one.
Okay, so we do have to plug one into the other. Can anybody tell me which one gets plugged into which? Eventually?
G of x gets plugged into
G of x gets plugged into f of x. G of x gets plugged into f of x. That's the first step. So it's square root of x plus 1. And actually, it's the last step. There's no simplifying to do. No like terms, nothing to reduce. So we're done. Now, the bottom one. Renee, can you just tell me what I'm going to do to set up the bottom one?
Are you just going to put x plus 1 inside of the
Yeah, we're going to take f of x and plug it into g. So take f of x and plug it in to g. So now it's the square root of x plus 1. Now thinking back to transformations from yesterday, we should be able to figure this out. What's the plus 1 on the top one going to do? Which way would that shift it? Yeah.
Up one.
Yep. Up 1. And the plus 1 on the bottom, just to make this very clear, which way would the plus 1 on the bottom shift it? Yeah, Emily?
To the left.
To the left one. Yep. Because that one's inside the function. It's not outside. Yep. All right. Okay, so here's 2 more. We're going to compose them. We don't have, well, yeah, let's do it both ways. We'll do f of g and g of f. Okay, so I'll compose it real quick because I want to just make sure we get to finding the domain. That's the important part. All right, so first one, plug f of x into g of x. So it's the square root of x squared minus 1. Now, to find the domain, we're going to start with the inside function. Jarek, what was the inside function?
I don't know. Oh, after that?
F of x, that's inside the parentheses. Okay, so look at f of x. What's the domain of f of x? And anyone can answer that. How about Ashley? I'm not sure. Anyone? I guess. Oh, Ron? Well, ask yourself, what kind of numbers are you allowed to square? You can square positive, that's part of it. Can you square anything besides positives? Yeah? You can square any number. So you can square any number you want and subtract 1 from it. You're not dividing by 0. You're not taking the square root of a negative in f of x. So there are no restrictions on the domain. So that's the first part. So let's go back here. Eliminate any values that do not appear in the inside function. There are none. So the domain from that part is all real numbers. All right, let's go scroll down. Second thing we have to look at the composed function. Is there anything we have to be careful about here? Okay. So looking at the final answer, how about Nathan? Anything we have to be careful about in the composed function?
It has to be able to be squared. Rooted.
And what kind of numbers are you allowed to square root?
Pretty sure you can do that to all of them, right? Not the irrational ones.
You can square root pi.
Okay.
Yep, you can square root pi.
Yeah, I have no idea. I'll just say all of them then.
All of them? Careful, I keep saying those 2 things you can't do. What can't you do with square roots, Chris?
A negative number.
You can't take the square root of a negative. Okay, you can't do that. We're dealing with just real numbers right now. So if you can't take the square root of negative, Chris, that means you can take the square root of any number that is or 0. So we just have to make sure that this is greater than or equal to 0. The radicand, what's under the root, has to be greater than or equal to 0. Oh. Let's move the 1 to the other side. And let's just look at that. The domain here is all numbers such that when you square them, the answer is bigger than 1. So what numbers can you square? And they will come out bigger than or equal to 1. Yeah.
-2 and then up and then -2 and down.
What about like 1.2?
Oh, so then 1, not 1.
Not including 1, yep. So you can square any number from 1 to infinity, and it will come out bigger than 1. Or you can square any number from negative infinity up to, but not including negative 1. And that will also come out bigger than 1. Okay? So the range here is any number that basically has an absolute value greater than 1. You could think of it that way. Just nothing between negative 1 and 1. Okay, any questions on the domain? Okay, so let's compose it the other way. F of g of x. So take g of x, plug it into f. So if I do that, I'm going to get the square root of x squared minus 1. And Joe, is there anything I can do there to simplify that?
Well, you can square the square root of x.
Yeah, so we just get x. And there is our final answer. Now the domain. Always start with the inside function. So Jacob, what was our inside function?
G of x.
G of x. Okay, g of x, if I go back up, is this. Are there any restrictions on g of x?
Can't be negative.
Can't be negative. So what kind of numbers can you pick? Like if I wanted to write it down from...
0 to infinity.
Exactly. G of x has a restriction from 0 to infinity. Now that's not the final answer. That's that. Now look at the final answer. The final answer is x minus 1. Are you dividing by a variable when you have x minus 1? Well, kind of. No. Are you square rooting a negative in that box? No. So there are no additional restrictions on the final answer. So the only restriction comes from the inside function, which was that it had to be greater than or equal to 0. Or you can write it this way. So let me type that in and show you what happens. Well, if you just type in x minus 1 and hit graph, calculator will graph it, even in the part that it's not supposed to. And that's because the calculator doesn't know originally you had a square root of something squared. If you tell it that, then it will graph it correctly. So let me show you how to do, let me type it in that way. Type in the square root of x, put it in parentheses, and square it, and then minus 1. You're not going to get the same answer that you just got. Notice now it does not draw the line in the part of the domain that doesn't exist. It only draws it 0 and up, which is what you're supposed to. All right, so if you cancel a square root, you got to be very careful. You go back to that inside function and check it out. Okay, any questions on that one? All right, so range. Range is a little harder. Range is basically, okay, now you know the numbers you can plug in. If you plug those numbers in, what kind of answers are you going to get for y? So in order to determine the range, the first thing is to figure out the domain. What am I allowed to plug in? And then every function is a little different. So there's no formula I can just say do this and here's the range. Basically, take the domain, try plugging in a bunch of numbers from it, and see what happens to the y values. That's where I usually use the graphing calculator to make a table, and then I can try a lot of values real fast. I can also look at a picture on the screen, see how high and low it goes, and that'll help me as well. I'm not going to do g of f and f of g. Let's just do it one way. Let's just do the first one. Let's just do g of f. Okay, so I'm going to take f and plug it in to g. Any questions on that? Okay, Gabe, if I plug in what I'm showing right here, what would be my answer?
X squared minus 3.
Well, there's no exponents of 2 here. So to have something squared, we'd have to have an exponent somewhere. But there's no exponents.
Is square root of x in parentheses squared minus 3?
Nope, there's no squared.
No squared.
Nope, there's no exponent of 2. So that square root's not going to cancel out this time. Literally, you're just going to change what's in that box with what's in that box. And that'll be it. So what would you get?
Square root of x minus 3.
That's it. Square root of x minus 3. No squared. Okay, domain. Look at f of x. What's the restriction on f of x, Tori?
Negative numbers or 0.
So can you just tell me what you can use?
Like, I'll go with positive.
Positives and 0 you can use. Okay, you can take the square root of 0. 0 times 0 is 0. So from the original inside function, we have a restriction of 0 or higher. Kaya, how about the final answer? Anything we have to be careful of there?
Then -3.
Subtracting 3 from something is okay. That's not a problem. But how about the square root? Is there anything we have to be careful about with square roots?
Well, you can't have a square root that's 0.
Nope, you can do 0. You can take the square root of 0. That's okay. What can't we take the square root of? Yeah. A negative. So the restriction you get on the composed function is exactly the same as the restriction on the inside function. There's no difference. So this time the restriction is just greater than or equal to 0. Yeah, not sure if someone ever told you can't take the square root of 0, but you definitely can. Square root of 0. If you type it in. Oh, just trust me, you can. Now the range. So let's graph it. So we've got the square root of x minus 3, and nothing canceled, so it's not like if I type in the final answer like the last problem, where I had to be careful because I canceled the square root. That's just the final answer. Nothing special about it. Square root of x minus 3. So square root of x. It is important that the minus 3 is outside the root, not like I just did. So just hit the arrow, and that's what you want to type. Okay, so what does it look like the lowest y value we ever hit on this graph is? Yeah, Justin?
-3.
Yep, I agree. -3. And how high is this graph going to go? Any guesses? Yeah? It's infinite. If you're not sure, go to your table and see if it's getting closer and closer to a number as you make x bigger and bigger. To me, it doesn't look like it's getting closer and closer to anything. If you make x bigger and bigger and bigger, it looks like y just keeps getting bigger and bigger and bigger. Okay, so it's just going to keep going up. So your range is what Justin said. Starts at -3. In fact, it hits -3 right on the axis. If I hit trace, you can see that. So 0, -3 is a point on the graph. So -3 up to infinity. questions on that one? So domain is not too bad with a composition function, just takes a little practice. All right, so we talked a little about transformations on parabolas yesterday. Now we're going to look at how we can write a transformation as a composition. All right, so you really don't have to write this, just what's underlined. All right, so this is kind of working backwards a little bit. I'm telling you the answer to the composed function. It's a times x squared. That would be a vertical stretch. Okay, you put a number in for a. I'm telling you one of the original functions, f, is x squared. I want to know the other original function. I want to know what g of x would have to be to get this as an answer. So in other words, what would you have to plug that into to get ax squared as the answer? You have to think backwards. So if you look at the original, well, that's x squared, so that's already part of it. But somehow you're getting an a in the final answer. So that has to come in when you plug f into function g. That a has to pop up there somehow. Yeah?
Like, can I see the answer?
Sure.
Is it just ax?
Yeah, just ax. Because now, if you take f of x and plug it into g, that right here. F of x is x squared. That, what I'm pointing to, would turn into x squared with an a in front. And that's what they said you should get. So it's just kind of thinking backwards a little bit. You got the final answer, you're figuring out kind of the first part of it. All right, let's try this one. It says g of f of x equals x squared plus k. F of x here is the same as it was up above. So f of x is still x squared. Does anybody see what g of x would be this time? Yeah?
Would it just be x plus k?
Yep, just be x plus k. Because if you take f of x and plug it into g, you'd be plugging x squared into g. If you plug x squared in, right there, you get x squared plus k, which is what they wanted you to get. So this is your final answer. So we just wrote a vertical shift as a composition, and we just wrote a vertical stretch as a composition of two functions. This I'm not going to spend a ton of time on. We talked about reflecting over the x-axis. What we didn't talk a lot about is reflecting over the y-axis. And that's because parabolas, if you reflect them over the y-axis, they look exactly the same. You can't tell the difference. But if a function is not symmetric, like a parabola, then you can tell the difference. All right, so basically, if you put a negative in front of the function, like we did yesterday, that causes a flip over the x-axis. If you put a negative with the variable inside the function, okay, not out in front, inside, that causes the graph to reflect over the y-axis. Okay, and I'll show you that real quick. So x plus 3 squared, negative x plus 3 squared. So you're going to see the exact same parabola mirror imaged over the y-axis. Eventually. And there it is. Okay, so it's a mirror image over the y-axis. Again, only makes sense if you shift the parabola off the vertex off the origin, so then you can actually see the difference. Okay. Any questions on that? All right. So actually, I think I have this on the next page. Yeah. So I've got all the transformations that we did yesterday kind of summarized right here in general. So not just for a parabola, but generalized for any function. Whether f of x is a parabola, whether it's a square root, doesn't matter what it is. Okay, so in the formulas I'm about to use, you'll see the three letters A, H, and K, and they represent positive real numbers. Okay, fractions, decimals, positive real numbers. All right, so on the left is going to be the transformation. I'm just going to write it out in words. And on the right is what it would look like as an equation. So vertical stretch or shrink is when you multiply by a number in front. 2x squared, 2 square root of x, whatever it is. Put a number in front, that's a vertical stretch or shrink. How about shifting up and down? What operation do you use to shift up or down? Blake?
Adding or subtracting at the end.
Adding or subtracting at the end. Perfect. Add goes up, minus goes down. What if you want to shift left? What operation do you use to shift a function to the left? Yep.
Isn't that the adding of the in parentheses?
It is adding or subtracting in the parentheses. One of these will be adding, one of them will be subtracting. If you want to shift left, do you add or subtract? Yeah. So to shift left, you add. Okay, if you want to shift left, you add. If you want to shift right, you subtract inside your function. Okay. If you want to reflect something like we did today, where do you put the negative to reflect over the x-axis? Inside or outside? How about Kathleen? Think you could tell me where you put the negative to reflect over the x-axis?
Outside?
Inside.
Inside?
Yep, so you put it inside. Wait a minute. Oh no, you were right. I'm sorry. You were right. It's outside. I mixed them up. So yeah, when you want to reflect on the x-axis, that's what we did yesterday. That was out in front. When you want to do the kind of reflection I showed you today, that's inside. Okay, any question on that? So it's just kind of generalizing all the transformations. We're going to go through more specifically for other kinds of transformations, but that's in general how all transformations work. All right, so the last one we're going to look at, there'll be some in the homework like this. There's no formula for that at all. It's just a picture. And I want you to transform it, okay, doing certain things. What am I asking you to do to the graph up above? Or let's start with how many things am I asking you to do? Yes? Yep.
You gotta do 3 things.
Yep, you're going to do 3 things to that graph. Nothing you do in this problem is numeric. It's all visual. Can you tell me the first thing that I'm asking you to do to that, Nathan?
Stretch it to
That's going to be the second thing.
Oh,
But I agree, we are going to stretch it by a factor of 2, so you're going to double all the y values.
go left one.
We're going to shift left 1. So we're going to take all these points and just shift them left 1. So start by doing that. Okay? First thing. Second thing is stretch what you just did by a factor of 2. Stretch which way? Vertically or horizontally? Oh, Rachel? Vertically. So I'll do this one in blue. Double all my y values. Where would this point go if I double its height? The one that's on the axis. Yeah? Stays right where it is. So that one stays where it is. That one stays where it is. Originally, we had one at a height of 2. It's going to go up to a height of 4. So now in blue, you've vertically stretched it. Again, you're not doing any math at all, just it's all visual. And then what's the last transformation asking me to do? Shift down 3. So the final answer would be what I'm about to draw in green. Shift down 3, down 3, down 3. So if you were doing it, that's green is all you need to draw. That's the final answer. Okay, I had a separate grid, but I didn't use it. Any questions on that? Okay. So, homework tonight on page 66. We'll take a look at that tomorrow. That finishes up chapter 1. And then we'll also finish up everything for the week tomorrow, and we have our test on Friday. Don't forget, I'll be here for extra help if you need to come by on Thursday.